How you going guys? Curtis from Cutting Edge Engineering. Today's job we're going to be rebuilding our 150 ton hollow jacking cylinder. Basically this is a portable hydraulic press that can be used for heavy lifting, pulling or pushing. And this is ideal for situations when you can't use a standard overhead press or when you're out in the field trying to do a repair. This is a double acting cylinder. There are two hydraulic ports that are used to feed oil in and out to cycle the cylinder, and it can be run up to 10,000 psi to reach the 150 ton capacity. And this has a 2.5 inch bore, a 5 3/4 inch rod and a 5 inch stroke. We actually acquired this cylinder secondhand when we started the business, and the company I got it from had it for about 25 years. I know it's done a lot of work and I don't think it's ever been rebuilt, but we're going to need to rebuild it today because I blew the seals in it. And what I was using it on was the bogie assemblies for the track frames off a D11T bulldozer, and I had to remove the pins that connect the minor to the major bogies, and they were the tightest ones I've ever come across. And it probably would have worked out okay if we only had the pins for these two cannons, but we actually had the entire bogie assembly from a set of track frames that needed to be done, which was a total of 16 pins. And the whole reason we're removing these is the pins have run dry and started to wear out, and if they don't catch them in time, it starts to do damage to the rest of the undercarriage. So the customer actually tried to remove these pins using a 60 ton jacking cylinder. They were unsuccessful with that, so they sent them to me. According to OEM procedure, we should have been able to pull out the entire pin assembly using 100 tons of pressure. We were unsuccessful with that, and all we did was damage 3 pulling rods. By the time I got to the 3rd rod, this was definitely a patience testing and character building job. These are made out of 4340 high tensile material. As you can see, the threads have been stripped off the rod, and these actually started out at 800 mil long, and they are now 815. Because the material has been stretched and they are fatigued, these will be going straight in the bin. So obviously that wasn't working. What I decided to do was gouge the welds out from the center pin that hold it to the outer sleeves and remove the center pin. That way I could use a larger diameter pulling rod and pull out the outer sleeves. And that worked out okay, but we were on the maximum capacity of the pulling rods and the jacking cylinder. And it was on about the 5th set of outer sleeves where I lost pressure in the hydraulic cylinder and it bled oil out everywhere, and I knew I'd blown the seals. But luckily I was able to borrow another 150 ton cylinder from a local earth moving workshop where my brother works, and we were able to complete the job. And the reason I believe they were so tight was only because of rust. It had locked everything in place and didn't allow them to move. In the past, when I have done assembly on track frames, we make sure the bores of the minor and the major bogies are completely polished, and then we cover the bogie pin in anti-seize and press them into place, and that creates a barrier to stop any moisture from getting in. And it is pretty obvious that they didn't do that for these. And I'm sure some of you are wondering why we didn't just gouge them out. The reason for that is those pins use oil to lubricate them, and gouging them would just blow hot black oil everywhere and make an absolute mess. And we'd also have to be very careful that while we were gouging out the outer sleeves, we didn't accidentally touch the bore of the major bogies or the minor bogies, because that would damage them, and that would mean they would have to be repaired as well. And the way the oil is retained in the pin assembly, there are duocone seals on the outside of the sleeves, which create a mechanical seal, keeping the oil in place. And if you're wondering if there's a video of me doing this job, unfortunately there isn't. We just didn't have the time to film it. But if there is enough interest in watching me pull out 16 pins, we'll do a video in the future. So now you know how we broke the jacking cylinder, now it's time to rebuild it. Before we pull this apart, I am going to hook it up to the power pack off our workshop press and cycle it so we can show you where it's leaking from. When I'm using this for track frame work, I don't use the power pack off our hydraulic workshop press because it is only rated up to 3500 psi. I do have another power pack in the container that is rated up to 10,000 psi, but it is very slow.
Oh dear.
So as you can see, it is leaking quite a lot from around the inner sleeve, and I'd say there's going to be quite a bit of seal damage because it's bypassing that much oil. And I'm hoping it is just a seal kit and we don't find any other damage, because that will determine whether we can even complete this rebuild today. Trying to get it going that way.
Oh! Oh no. yeah, it's just leaking all over the place.
The first thing we need to do is remove this gland nut that retains the rod into the barrel. I'm just going to remove the grub screw that is locking the gland from spinning and coming undone. And I can see that there are 2 center pot marks on the outside of the gland nut. They are only small marks, you wouldn't think that would cause a problem, but that could definitely lead to problems with the threads galling. So now we're going to use our shop-made pin spanner to undo the gland nut, but before we do that, I need to make up some smaller pins for it. And to make the pins, I'm going to be using 2 M16 bolts that we salvaged off the Toshiba milling machine. And all we need to do is part them to length and machine them down to 7mm to suit the holes in the gland nut.
Okay. Wait.
So there is no way I'm going to get this undone like that. So we're going to take it over to the Zaya and get it clamped down.
Oh, look at all the grease. Oh, yeah. Oh, it's split. And then that one's split there. Oh.
There's more.
Okay.
So that's the first sign of damage. Those seals are coming apart, but if they are original, I'm not surprised. So we're just going to tip out the rest of this oil, and I'm also going to remove the bottom hydraulic port so it doesn't create a vacuum when I try and pull out the inner rod.
Get me to hold the jug.
Fingers under it.
What's that? Here we go.
Oh my god, that's aluminium.
Whoa.
Oh,
There's the problem.
that'll explain it.
Oh, wow. Oh my goodness.
That's the rod removed, and surprisingly the entire thing is made out of aluminium, which is quite different considering all the other Porter Power stuff I've worked on has been made of steel. And after looking down the inside, we can see that both the wiper seal and the pressure seal have completely blown apart, and that's pretty much what I expected to find from how much it was leaking. And now we're going to bring the barrel back over to the bench so we can remove the inner tube.
Oh. What is that split? What's that?
Scratched. That's what's eating up that inner seal. Can't move this on the port.
Okay. Oh yeah. Oh. Yeah. Oh. Jesus. Wow. Whoa. Not too bad.
Considering.
Jeez. Oh my goodness.
The wiper seal.
Oh yeah.
Oh, yeah.
That's pretty good.
Yeah. That's steel, not aluminium.
Is it?
Yeah.
Weird.
Oh, that will be part of the pulling rod threads. I reckon the thread from the nut or the pull rod has gone down the inside and finished it off. So that's all the seals removed, and it is no wonder why it was leaking. But during the disassembly, we also found gouges on the inner tube and on the inside of the cylinder rod, which wouldn't have helped those seals. Over time, the more it cycled, the more it tore them up. And after digging around on the inside of the rod, we did find a few bits of swarf and what looks to be a piece of a thread off a pulling rod. Now we've got everything apart, we're going to get it in the hot wash and get everything cleaned up. Righto guys, so that's all of our parts cleaned. Now we can give everything a really thorough inspection. First inspection on the inside of the barrel is everything is in pretty good condition there. We might just need to give that a very light hone. The gland is also in good shape. There are a few water stains on the inside of it from where moisture has been sitting, but we'll just be able to give that a quick buff and they'll clean right up. And the cylinder rod, even though it is made out of aluminium, it has been hard anodized. There are a few scores running the length of the rod and there is a chip out of it, but I don't know enough about anodized aluminium to know if that's going to be a problem, but I do know a guy down the road that is an expert in it, so I'm going to take it to him and see what he thinks. And the scratch down the inside of the bore, even though that looks like the worst damage out of everything, that's not actually going to be a problem because that bore diameter is a clearance hole for the inner tube. But what is going to be a problem, the inner tube, the chrome on that surface has been damaged. There is a scratch in it and there is a little bit of pitting around the base of it where the cylinder would sit when it is fully closed. It looks like there has been a bit of moisture getting there and it has pitted that chrome, which means it's going to be a problem. Even though the damage doesn't look too bad, that score is definitely past the chrome layer. Over time, moisture will get into that scored area and it will begin to rust and it will lift off that chrome, and every time the seal goes past it, it will tear a bit of that seal off and eventually lead to a failure. And I don't want that to happen halfway through a customer job like I just experienced. So I will be sending this out to get a quote on how much it's going to cost to get it re-chromed. If it's too expensive, we could go through the process of making our own out of a piece of chrome bar. And obviously we do need to get a new seal kit, and to be honest, I think that will be the most expensive part of the rebuild. And we already did go through the process to see how much it would cost to replace this, and the cheapest one we could find at the highest quality was coming out of the USA for $7,800. And that's why we decided to rebuild it. That's something we are going to do while we've got it apart. We are going to draw up all of the various components, and that way in the future, if we ever need to make a new one or make replacement parts for this one, or even make a bigger one, we've got a really good place to start. So unfortunately, this wasn't just a seal kit. We are going to have to wait for an answer on the chroming and the anodizing of the aluminium, but sometimes that's just the way it goes, and you'll have to stay tuned for the next video. Thanks for watching.
That was awkward. Damn it, I dropped it.
And this has a 2.5 inch bore, fuck me. It has done a lot of work in its time. I don't think it's help. And it was about the 5th bearing that I was trying to pull out, and it was on it. And it, in the past when I have done assembly on the, fuck me, righto, and the gland on the fuck off train. We're just going to give them a quick polish to get rid of those. And obviously we do need to get, fuck me. And obviously we do need to get a new seal kit, and that'll, fuck me. And obviously we do need to get a seal kit, fuck me.
I'm sweating. I can see the temperature increasing like by the minute. Yeah, I know. So what's your plan? Oh my god. Okay. What, with your fingers?
Maybe.
Okay, now. Let's see if I can do this. Where I gotta angle it with you, so. Do you want it down, high? What?
Are you filming?
Just don't drop it.
Are you filming?
I'm filming. That's what keeps Curtis going.